All right, hi chemistry students. As promised, I said that I would go through our last example together from our notes today. So it says, how many moles of oxygen are necessary to react completely with 3.0 moles of propane, C3H8? Well, my first step is to check to see if my equation is balanced. And right now it looks like it's not. I'm going to double check. CHO, C, H, and O. All right, it looks like on my reaction side, I have 3 carbons, I have 8 H's, hydrogens, and I have 2 oxygens. And on my product side, I have 1 carbon, 2 hydrogens, and 3 total oxygens. Remember, we combine, we do 2 plus 1 to find the total atoms. So let's get started with balancing. Let's go and put, well, we have 3 carbons. We only have 1 carbon, so let's put a 3 here. 3 carbons, so we have 3 times 2, we get 6, plus 1, we have 7 oxygens. And now let's see, we have 8 hydrogens and 2 hydrogens. I know that 2 times 4 is 8, so I'm going to put a 4 in front of hydrogen right here. So we do 4 times 2, we get 8. And then we have 4 times 1, we get 4. 4 plus 3 times 2 is 6. We get 6 plus 4. We have 10 total oxygens now. If we look here, we know that 10 is evenly divisible by 2. So we're going to put 10 divided by 2 is a 5. We're going to put a 5 right here in front of oxygen. Now I should be able to double check. Okay, I have 3 carbons on both sides. Perfect. I have 8 hydrogens on both sides. Perfect. And I have 10 oxygens on both sides. Perfect. So now I have my balanced equation. Now I need to set up for stoichiometry. So what I'm going to do is I'm going to start with whatever I'm given over 1. Let's reread the problem again. It says, how many moles of oxygen are necessary to react completely with 3.0 moles of propane? And it says propane is C3H8. So what I'm given in the problem is 3.0 moles, remember MOL short for moles, of C3H8. I want to make sure I have every single thing labeled. So I have 3 moles of C3H8. So now what do I want my answer in? I want to know how many moles of oxygen. So that means I want my answer in moles of oxygen. So I'm going to put that on top. And I want moles of propane or moles of C3H8 to cancel out. So I'm going to put that on the bottom. Moles of C3H8 on the bottom. So now I need to plug in my coefficients. Remember, coefficients are the big numbers here. And if we don't have a number in front of propane, remember that is always a 1. So now we'll plug it in. We have 5 as our coefficient for oxygen, and we have 1 as our coefficient for propane. Now, remember, our coefficients form a molar ratio. So coefficients equals a molar ratio. So that tells us how they're related. So now we can double check and we can see that we have moles of propane on top and we have moles on propane on the bottom. That means what goes up must come down. Those two cancel out. So now I need to multiply all the way across the top. So I do 3.0 times 5. I get 15 moles of O2. Now I need to multiply all the way across the bottom. I do 1 times 1. I get 1. And now I need to divide 15 moles of O2 because we get 15 divided by 1. We get 15 moles of O2. That's how many moles of oxygen are necessary to react completely with 3 moles of propane. I know it might seem a little silly that we need to multiply all the way across the top and multiply all the way across the bottom before we divide because we know our bottom's going to be equal to 1. But starting tomorrow, when we're doing multi-step problems, it is super important that we multiply all the way across the top, multiply all the way across the bottom, and then divide. So we should get in the practice of doing that now. Please, please, please let us know if you have any other questions. I hope this was helpful. Thank you.